The first thing that you should do when watching this video is you should get out a piece of paper and a pen or pencil and pause the video and copy this table into your notes on your paper. So press pause now and copy the table. By the time we are finished filling in the table, you should know the word polynomial, monomial, binomial, trinomial, and you should know how to find the degree of a polynomial. You should know what writing a polynomial in standard form means, and you should be able to identify the leading coefficient of the polynomial. On the first row of the chart, the first expression that we see is negative 3z to the fourth. We've already learned this vocabulary word. This is a monomial. It's made up of a number called the coefficient, a variable, in this case z, and an exponent, in this case 4. And because there is only one term with no plus signs or minus signs, this is called a monomial. Fill the word monomial in on your chart. When you're trying to find the degree of a polynomial, in this case the monomial, the degree is the largest exponent on any term. And since we only have one term, the largest exponent that we have on a variable is a 4. So this is called a fourth degree monomial. When you write a polynomial in standard form, you put it in order so that the term with the largest exponent comes first, working our way down to smaller and smaller exponents in each term. So when writing a monomial in standard form, the only thing you need to do is write the monomial. And finally, the leading coefficient is the first number on the first term, or the first coefficient on the first or leading term. In this case, our leading coefficient is negative 3. On the second row of the chart, we have a polynomial that is 4 plus 5x squared minus x. So our polynomial is made up of 3 monomials joined together by plus and minus signs. So when you have 3 monomials joined together by plus and minus signs, it is called a trinomial. Now, when we look at all of the exponents, the variable with the largest exponent is the 5x to the second. So this is a second degree trinomial. If we want to write the trinomial in standard form, we start with the largest exponent first. So the first term we'll write down is 5x squared. The next term that we'll write down is negative x to the first. And the last term we'll write down is the 4, which technically is 4x to the 0. So that is our equation in standard form. And our leading coefficient, we look at the first term when it's in standard form, and that is our leading coefficient. Our leading coefficient is the coefficient 5 on the first term. If the video is moving too fast, please press pause and fill in the parts of the chart that you haven't filled in yet before you start watching the third row. The third row has 8q plus q to the fifth. So this is one monomial, 8q, plus a second monomial, q to the fifth. So that's 2 monomials, which is called a binomial. And when we look at the exponents on the variable, q to the fifth is the largest exponent on a variable. So this is a 5th degree binomial. If we write it in standard form, the q to the fifth will come first because it has the largest exponent on the variable, and then the term 8q will come second. So this is what it would look like if we wrote our polynomial in standard form. And the leading coefficient is the coefficient on the q to the fifth, which is an unwritten 1. So our leading coefficient is positive 1. By now, you may have figured out that the word polynomial is a general term for a monomial or a binomial or a trinomial, or if there is a polynomial that has more than 3 terms. Usually it is not named by a special name, it's just called the general term binomial. Now this last example on the bottom row has one twist to it that we haven't seen yet. Obviously, 1/2 AB to the second plus 2AB plus A, that's 3 terms, so this is a trinomial. But in order to know what degree trinomial is, we have to take both variables and add their exponents together. So we have an a to the first, we have an ab, that's an a to the first and another a to the first, so that would be a second degree term. But right here, we have a 1/2 ab to the second. The a has an unwritten 1 and the b has a 2, so this is a third degree trinomial. That's something that's important to know, but doesn't come up nearly as much as the other examples do in this class. If we write it in standard form, it would have the AB to the second first, then the AB would come next, and then the A. So our trinomial is already in standard form. And when we look at the coefficient on the very first term, the coefficient on the first term is 1/2. So the leading coefficient is 1/2 on this trinomial. We already know how to simplify a monomial. And if you look at every monomial that's on the board right now, every one of those monomials is simplified. We don't need to use any of the 5 R's to simplify them. But now our monomials are joined together by subtraction signs and addition signs. And so we have a trinomial here, and we're adding it to a trinomial here. What we need to do is combine this and that. So instead of having 6 terms, we'll try to have the least amount of terms possible. On this problem, there's a subtraction sign in between. This is a problem that a lot of people make silly mistakes when they're doing their algebra. On this problem, we're going to combine this and the opposite of that. So when you have an addition sign in between, this sign doesn't affect the signs of any of the terms in this trinomial. But when you have a subtraction sign, this subtraction sign does affect every sign in this trinomial. And so you're going to subtract this and the opposite of that, because that subtraction sign will change everything to its opposite. So let's start with this one. This is one where people normally get it right. We have 6 terms, but some of those terms are the same. They're called like terms. Like terms have the same variable and the same exponent. So I'm going to make some columns for each of my groups of like terms. So when I look, this is a 3rd degree monomial, and I have another 3rd degree monomial. So I'm going to make one column for x to the 3rd. And then I have a 2nd degree monomial. Here's another 2nd degree monomial. So I'm going to make a column for x to the 2nd. Here's an x to the 1st. There's no other x to the 1st, but I'm going to make a column for my x to the 1st. And there's a constant left. So I'm going to make a column for all of the constants. So now we're going to combine this and that. So in the x to the 3rd column, I have 2x to the 3rd. And it's positive, so I'm not going to put a sign there. And I'm going to cross it out to make sure that I don't forget any part. Now as I go down the row, I have another x to the 3rd right here. It's a positive x to the 3rd. So I'm going to put it in the same column, and I'm going to cross that one out. Okay, now I have x squareds in this column, so I have a negative 5x squared. And I have a positive 2x squared. right here. I only have one x term, so I'm going to put an x here. And I have one constant, which is a -1, so I'm going to put that right there. And so now I've gone through all 6 of my terms, and I've grouped together the terms that have the same variable and the same exponent. So now I'm ready to just finish the problem. This is going to be x to the third and 1x to the third, which makes 3x to the third. Remember, this is an unwritten 1, so an unwritten 1 plus 2 is 3. Notice when we're combining like terms, we're not adding the exponents. We're just counting up how many x to the thirds we have. Here we have a -5x squared and a positive 2x squared, which leaves us with -3x squared. Here I only have my x, and it's positive, so I'm going to put a plus sign now to join these together. And then I have a -1. So there's my simplified version where I've combined this and that. And instead of having 6 terms, now we only have 4 terms, and it's a third degree polynomial. And so my answer is 3x squared, or 3x to the third minus 3x squared plus x minus 1. Now here, I'm going to follow the same exact pattern. I'm going to make columns for each group of like terms. And remember, like terms have the same variable and the same exponent. So when I look at my 6 terms that they gave me in this problem, I have p to the second. I have some p to the first. I have some constants. And constants are numbers that don't have a variable attached to them. So it looks like out of my 6 terms here, I only am going to have 3 groups of like terms. So I'm going to start out, and I have my p squared. And then I'm going to cross that out. And I keep going down the line, and I have another p squared. And it says -4p squared. But I'm going to combine this and the opposite of that. So when I go to write this down, because we have a negative and a negative, the opposite of that is going to be positive 4p squared. So that takes care of my squared terms. Now here I have a positive p, and then I have a negative p. But I'm combining this and the opposite of that because it's a subtraction problem. So when I write this down, I don't write negative p. This negative and that negative make it a positive p. All right, now to my constant terms. I have a positive 3. And it looks like I have another positive 3, except I'm combining this and the opposite of that. So this negative sign and that positive sign together make it so that I should write down a -3. So now I've gone through all 6 of my terms, and I have them grouped together in like terms. So to answer the question, I just have to put my like terms together. 1p to the second and 4p to the second makes 5p to the second. A 1p and another 1p makes 2p. And positive 3 and negative 3 make 0. So I'm not even going to write that down. And these 6 terms can be simplified or combined to turn into only 2 terms. And my answer is 5p to the second plus 2p.